Hello everyone. I'd like to briefly talk about the issues and the problems that you come across when you try to achieve interoperability in the smart home. Now, this is a kind of excerpt of my talk that I gave at Java 1 this year, and I'd just like to highlight some of the problematic fields and the way that we try to address that in the Eclipse SmartHome project. Now, the general issue is that for typical smart home setup, you have many devices from many different vendors. They all come with their own app, and you have more or less many silo applications in the end. Eclipse SmartHome is a framework that tries to bridge all of these different devices in a vendor-neutral way, and also popular systems like Alexa, Google Home, and so on, all these voice assistants, they more or less have the same issues to deal with. Now, the very first thing that you have to do is to say you're not talking about a specific device from a specific manufacturer, but you really have to group them into some kind of categories, which means that you're looking for a classification system. So a classification is a systematic arrangement in groups or categories according to established criteria. If we do so, we're not talking anymore about a Philips Hue bulb, for example, but about light bulbs in general, like televisions, switches, fans, washing machines, and whatsoever. Now, if you start creating these categories, you will quickly come across questions like this one. What do you do with different kinds of light bulbs? Like you have some that are only switchable, others you can also dim, and again others you can adjust the color of them as well. Well, there's an easy solution. You can introduce subtypes to it. So you're not having just light bulb in general, but you have color bulbs, you have dimmable bulbs, and so on. Now, if you do so, you're not having a flat list of categories anymore, but you're now talking about a hierarchy, so a whole tree of categories. And with that, you're more or less now talking about a taxonomy instead. Taxonomy meaning here an orderly classification, and specifically also a complete classification. That means that everything fits into the scheme in some nice way. Now, if you do that for the smart home, we can say we have a parent category device, and underneath that we now have the light bulb, a switchable bulb, dimmable bulb, and so on. Same, for example, for sensors, where we have temperature sensors, humidity sensors, and so on. So that would be our taxonomy, and if we're now going ahead and trying to define all of this, we again come across some issues like how do we want to deal with multi-sensors? For example, there are many devices that are a presence sensor, and at the same time they measure the light in the room. Or you have a weather station that measures the temperature, humidity, and wind, and other things. Now, you could come up and say, let's create a category for any kind of combination, but that very quickly becomes much too complicated, and it isn't even clear where exactly would fit in this new category for this combined sensor. Is it a parent category of a humidity sensor? Is it a subcategory? Or how would you deal with that? And actually, normally taxonomies are used for plants and animals, and nature made it easy that there's always only exactly one parent, so it's easy to come up with a tree structure there. While for the smart home and for things around us, we see that it's not that easy to come up really with a simple tree for your categories. The solution to that is that instead of trying to have very fine-grained categories, we rather go for describing the functionality and leave the device categories at a bit higher level. So we could simply say we have a device type which is a multi-sensor, and it has the capability or functionality to measure 5 different things, which are temperature, wind, and so on. And by that, we are now really able to more easily describe the devices that we come across, because many of them have subtle differences in what they offer and how they can be used. But with leaving now the tree structure and introducing new words like functions or properties that can be measured, like a temperature and so on, we're now not talking about a taxonomy anymore, but about an ontology, which means that you are really describing a full vocabulary of different things, and you associate your terms with each other for describing your world. With the word ontology, many people run away because it's very academic to them, and if you look at the definition here, this might really be a concern, because it's a branch of metaphysics and a particular theory about the nature of being or the kinds of things that have existence. So something rather abstract and not easy to deal with. So let's have a look at a concrete example in our case. So we were talking about the multi-sensor, and we could now simply describe this device as being of a certain type, a sensor, having 2 capabilities, which are both of the type measurement. And the first one measures a certain property, which is temperature. The second one, a property, which is illuminance. With that, we now really have a way to very flexibly describe everything that we come across. And what is missing is a kind of base data system. So something like we say, well, we can map switch, whether something is on or off, to a Boolean value. We can have measurement values as floating point numbers of a certain type. And so if we're fixing that kind of base data system, then we more or less have reached interoperability at some level. And to be exact, that's actually a syntactical level, which means that on the code level, we are now able to say, well, okay, this one has exactly this kind of input, and we can map that and forward that to another device. So as a programmer, we are now able to really make a system that includes all of these different devices into one system and makes use of that. Just to have a brief excursus to see what others have come up with here. So this is what you can find in the Alexa Smart Home skill documentation. They more or less came up with 6 different kinds of device types: camera, light, smart lock, smart plug, switch, thermostat, and also then having a more fine-grained level which describes then the functionality of the single devices. Just picking the light as an example, you can switch power, brightness, color, color temperature. These are the things that are offered here. For Google Home, it's even a bit smaller list only available: light, outlet, switch, thermostat. We see it's pretty similar. Also, apart from the wording, the functions here are really pretty much the same. Now, looking at Apple HomeKit, we see that there's a much longer list defined already for different kinds of devices. But to be fair, the very first specification of HomeKit also just comprised this list here, which again is fairly similar to the other ones we've just seen. The interesting part on this list is that it's chronologically sorted how things have been added to the specification. And the further we look down the list, the more weird things we're coming across here. Or let's say we see that actually describing devices has more and more been replaced by describing functionality or services, as it's called in Apple HomeKit. So, for example, we see here a stateless programmable switch, which doesn't really describe a physical device as such, but it's rather a category meant for any kind of triggering device that is something like a wall switch, but not being a wall switch. Also, battery service. It's not about a battery being a device here, but it's about devices that are battery powered and as such can have a battery level, they can have can be charging, they can be low on battery and information like that. Interesting is also the FEN version 2. So we see that FEN has been the very first device that was specified. And at that time, it seems to be very straightforward. So you have a rotation speed, you have a rotation direction, and that's more or less it. For the fan version 2, it was noticed that a fan can also oscillate, and you actually need to describe some more about it for these kinds of devices. So a fan version 2 has been introduced here. And that already shows that fixing the set of functionality for device type is generally not a good idea. So in things that came further then, like an air purifier here, which has a filter and slats, you see that this has been already taken apart into different services that are reusable by different devices in the future, so that it's easier to be flexible with new stuff that comes up and which you didn't have in mind before. So have we reached our goal with that kind of device descriptions now? Not exactly. If we take a step back and look at what we actually want to achieve, it's to be able to express something like set the room temperature in the kitchen to 22 degrees Celsius, or notify me if a window opens while I'm away. What you're noticing when looking at these expressions is that we're actually not talking about devices at all here. We're not saying, please adjust the target temperature of my smart thermostat in the kitchen to a certain value, or please set the lock state of my smart door lock that is attached to the entrance door to lock whenever my presence detector in the bed tells you that somebody's in it. But we're really talking about the objects around us in a normal way. Additionally, we also find that we mention places a lot, like the kitchen or the outside and things like that. So from looking at these examples, we're actually seeing that our ontology is missing words in its vocabulary. And to come back to our initial definition here, we now see building objects, something like doors, windows, outlets. It doesn't matter whether they are smart or built into the house itself, things like that, as well as places, kitchen, bedroom, living room. Our vocabulary has therefore increased by quite some additional types of words here. Now, looking at some further examples, we're also saying that, we want to turn off the lighting, and not saying turning off all our light bulbs. We're talking about energy consumption. We're talking about the heating, not about a certain radiator, for example. And also about things like an intrusion when we want to have an alarm activated. All of these describe the purpose of our expression or command, so more or less the target that we want to measure or that we want to control. So coming back to our vocabulary, we have to add purposes here as well, and again that can be added in multiple levels. So we can have lighting for illuminating the room or just as some ambience light. We can have different kinds of alarms for intrusion, for leakage, for fire, and so on. So again, this is a whole new set of words that allow us to really describe our intentions. Coming back to our example with the multisensor, that means that we should add information about its location and its purpose. So, for example, we say the location is outside and its purpose is to measure weather data. Now, these two pieces of information is actually something that cannot be defined by the manufacturer of the device, because it very much depends on the installation of a certain smart home, because nobody knows where the user will place the device in the end and what he actually uses it for. Another example of a device that I usually like to validate a modeling approach is this one that I have in my electrical cabinet. So a rail-mounted device, a multi-channel actuator. So more or less just a bunch of relays that can switch more or less anything within the house. And we now see that the location of that device is actually not very interesting and not very helpful, because, well, the location is the electrical cabinet. What we're rather interested in is the location of its function, because the one channel might switch the light in the kitchen while another channel switches the fan in the living room. So we actually have to provide purpose and location not on the entire device, but on its single capabilities or functions. And with that, we end up with a description like this here. At this point, we notice that we're not talking about devices anymore, but rather about services, about functionality, information that has some local impact. And just to take the example of the weather station again, for the end user and his use cases, it's really not that relevant whether it's a physical weather station that is connected and provides the outside temperature, or whether it's a web service which provides that information for his location. And so we see that we really have to look at the use cases in an abstracted way and not focusing too much on the device that provides that information. Now, for me, this is then really the WWW of the smart home, the what, why, and where. The what is the capability, so what is this device capable of? It can measure a temperature. The why is its purpose. What kind of temperature is it? What does it help us? Well, it's here, the weather outside temperature. The where is the location. Where is this device placed, or rather, where is the functionality of it located? And for this one, it would be the outside. It could be the kitchen, then it would be a room temperature instead. So these are really the three parts that you need to describe in order to be able to build use cases and to have a machine understandable way to access all your system and information. Let me now explain how Eclipse SmartHome deals with that. One of the core concepts in Eclipse SmartHome is that of an item. An item is the most fine granular piece of information that you want to control, access, or simply work with. It's a purely functional modeling, and the item itself is described by a name, a label to be used in UIs. It has a state, and you can send certain commands to it. There is a fixed set of item types available in Eclipse SmartHome, and you can find some which are comparable to primitive types in programming languages, like a switch for Boolean value, a number, a string, but also more smart home specific stuff like a color value, a dimmer, a roller shutter, and so on. Items can also be grouped and on this page you can see that there is a group for an object, for a window to describe its properties. There is another group for a place, the kitchen, so that all of these functions are located in the kitchen. This is explicitly expressed by this. And so you're very flexible in building a functional model of your environment and of your whole system. Now, the physical devices are called things, and they are mainly needed for describing the entities that you can add to your system that need to be configured and set up in order to be operational in the end. These things are described as a list of channels, which are the functions that they expose, and these channels can then be linked to items. And by having these links explicitly set up here, you can decide which of the functions should actually be exposed and which are not relevant for your setup. On top of the functional level, there are the so-called semantic tags. These are now the last W, which is the purpose. So by adding tags to your items, you can specifically define the purpose, what you are actually using that for, and this information can be used by rules, by predefined use cases to automatically determine whether some item should be used or shouldn't be used for that use case. We see that Eclipse SmartHome has the technical foundation to provide every information that is required to have full interoperability, because we have a full description of the technical aspects as well as the semantic aspects of a system. We are currently just getting started in defining the vocabulary for Eclipse SmartHome, and this will certainly be an ongoing effort as the definitions and the vocabulary will evolve over time, and the more devices are supported, the more is learned, the more might be harmonized in the end. With that, I'm at the end of my short presentation, and I'd like to welcome you to join the efforts on the Eclipse SmartHome project if you want to contribute something to it. And I'd like to thank you for watching this video. Bye bye.